Hi, I'm Jared Hillam. Have you ever just about bought something and suddenly it's out of inventory and your transaction got canceled? Well, next time it happens, you can think the I in ACID, which stands for isolation. Let me give you a really low level example of isolation. Imagine you had to do 100,000 lemonade transactions all at the same time. And let's say that one of the transactions was for 7 lemonades and the other was for 2 lemonades. Imagine if there was no isolation in the database between these two transactions. Like, what if transactions for 2 lemonades could be overwritten by 7 lemonades? Well, of course, you wouldn't want that, and you'd need to ensure that every one of those transactions was isolated from each other. So in the crazy flurry of 100,000 transactions, each one could be treated as its own little world without any risk of another transaction mingling data. Now, that's a very basic version of isolation, but concurrency isolation goes much further than that. For example, what if the same 2 people were buying, but you only had 7 cups of lemonade left to sell in your inventory? You can't sell both because that would require 9 cups of lemonade. So transaction isolation can get really tricky because it can include a lot of concurrency rule sets. So an obvious rule is that the person who clicks the buy button first gets the inventory. Transaction isolation rules are all over the place in the database. And it's one of the primary things that database vendors monkey with to eke out concurrency performance. But often databases will lock an object to ensure that nothing can touch it while a transaction is happening. And this is what ensures isolation. All right, now in our next video, we're going to go over the D in ACID, which is durability. So stay tuned.